Hey guys, this is Mr. Grice for Algebra Unit 6.4 Notes Day 2. Today we are continuing our discussion and now applying the compound interest formula. Now, the learning target is to be able to apply the compound interest formula to real-world situations. Okay, now some important vocabulary words. We've got 4 words that are extremely important to compound interest. Okay, first is semi-annually. Semi-annually means 2 times a year. Quarterly, if you guys think of your root words, quarts. Also, for some of you Spanish speakers, cuatro. Okay, 4 times. Next, monthly. How many months are there in a year? You better not be saying 52. And then the last one is weekly. How many weeks are there in a year? 52. Okay? So, we're going to be talking about compound interest, and that's an interest formula that's used in a lot of savings and checkings accounts with banks. So, compound interest, it looks a little bigger, and you got to pay very close attention to some things. First off, it starts off with A. It's no longer Y equals, it's A. And what A is your account balance. Okay? It's your total. It's what you find out what you have at the very end. Okay? Now P stands for your principal. Okay? And what that is the money that you start with. So that's your starting amount. Okay? R is still your rate. And you want to make sure that you take the percent to a decimal. Okay, and N is the new word or new variable that we have, and that's the number of times that the interest is compounded per year. And that's always going to be written as one of the words, semi-annually, quarterly, monthly, weekly. Okay? And then, of course, the one variable that we forgot, just remember that T is still your time. Okay? Now, if you notice something, N is in there 2 times. Okay, it's in there twice. So you got to be very, very careful about it. Now, the nice thing is you don't have to memorize the formula. You just have to memorize which words goes with the formula. So the key thing to memorize is this part up here. Okay? All right, let's get started. It says use the compound interest formula to solve the following application problems. When Raul was born, his grandparents deposited $3,000 into a college savings account, paying 4% interest, compounded, and it's compounded quarterly. Just remember that compounded is the key word saying that we need to do the compound interest formula. Okay, so I think it's good that we just start by writing the formula. A equals the P1 plus your rate divided by N times T. That's what NT at the very top means. Okay, so P, principal, how much did we start with? $3,000. Our rate is 4%, and that 4% is 0.04. N Okay, n is how it's compounded, and it's compounded quarterly. And quarterly means 4. And the last thing is time, and time is in our letter A, assuming there are no deposits or withdrawals from the account. They want to know how much is in there after 10 years. Okay, so let's plug everything into your, or write everything down first, okay? So we have 3,000 times 1 plus our rate is 0.04 divided by 4. And then the NT is just n times t. So 4 times 10, 4 times 10 is 40. That's one of the few things that we're going to simplify right off the back, okay? And now from this point, you can put everything into your calculator and it'll spit out the answer. You just have to be very careful how you put it in. So we have 3,000 times 1 plus 0.04 divided by 4, close the parentheses, and that's all raised to the 40th power. Okay? And then we get our answer. So the amount of money that would be in that account would be $4,466. And we need to round, so I'm going to look at that 1. 5 or more, raise the score. 4 or less, let it rest. So 59. Okay, now looking at the next question, part B says, what will the balance be after 15 years? Okay, so the principal, that stayed the same. The rate is still 0.04. It's still compounded quarterly, but the only thing is changing is the time. Be like, well, that doesn't make a big difference. Well, yeah, it does, because we have to do 4 times 15. And 4 times 15 is 60. So it's being compounded 20 times more than the previous amount. Okay, so let's just plug everything in again. We start with 3,000, 1 plus 0.04 raised, or divided by 4. And then remember, it's n times 4. That's where that 60 comes from. Okay, so plugging it into our calculator, we have 3,000 times 1 plus 0.04 divided by 4 raised to the 60th power. Okay. And so the amounts that would be in there, we're talking about money, so I'm using the $sign. So just by staying in there 5 more years, you have another, pretty much another $1,000 that have been deposited into that money, or interest that was earned. Okay? All right. Let's look at Josie. When Josie was born, her grandparents deposited $3,000 into a college savings account that pays an 5% interest compounded semi-annually. Okay, so 3,000, 5% interest. There's that compounded again, and now it's compounded semi-annually. Okay, so assuming there are no deposits or withdrawals from the account, what will the balance be when Josie is 12? Okay, so P equals R equals N and time. So once again, we're starting with $3,000. Our rate is 0.05. Semi-annually means 2. And then if it was when she was born, to now, or till when she was 12, that's a total of 12 years. Okay? So 2 times 12, let's do that first. We get 24. I'm just going to write down the formula again so we remember. 1 plus rate divided by n times t. So we have 3,000, 1 plus 0.05 divided by 2 raised to the 24th power. 3,000 times 1 plus 0.05 divided by 2 raised to the 24th power. Okay, and take a look. Do we have to round this one? 5 or more, raise the score. So our final answer, after 12 years, she will have $5,426.18. But she doesn't need that money when she's 12. She needs it when she's 18, when she's going to college. So how much will it be then? Well, let's find out. The principal is still 3,000. The rate is still 0.05. N is 2, except now the time is 18. Okay, and 2 times 18 is 36. So let's plug in the new numbers. Oh, 36. Okay, let's see what we get. 3,000 times 1 plus 0.05 divided by 2 raised to this 36th power. And so if it stays in there another 6 years, now she has how much? Make sure to round that number correctly, guys. If you cannot round this, you need to come see Ms. Carranza or myself. 5 or more, raise the score. 4 or less, let it rest. Okay. Let's look at number 3. In 2002, Lord deposited $10,000 into an account in order to start saving money for a down payment on her house. Her bank compounds the interest monthly at a rate of 2.5%. Okay, so I want to see if you guys can set this one up all by yourself. Okay, so go ahead and pause the video and good luck. Okay, so before I set this up, I just want you guys to look to see what I got on my left for all of my variables. All right, you might be like, Mr. Grice, I did not get 8 for the time. I got 2010. Well, unfortunately, you didn't read the question right. It said, what will it be in 2010? She started it in 2002, so you have to subtract those to get the number 8. Okay? Now, if you need more time, go ahead and pause it one more time, and then you'll see the answer. Okay, and then you get a final answer of $12,211.47. Okay. Next one says, what is her current account balance? Okay, so current, well, what year is it now? Hopefully you're saying 2014. All of her other information stays the same. It's still compounded monthly. But the time, well, now we're doing 2014 minus 2002, and we get 12. Okay, so now we have to find out, well, n times 12, 12 times 12 is 144. So now plugging everything in, 10,000, 1 plus 0.025 divided by 12 raised to the 144th power. Okay? Let's find that number. So 10,000. I guess this isn't going to work for me real quick. So we got 10,000 times, oh, nope, it's not going to let me, times 1 plus 0.025 divided by 12, close the parentheses, raised to 144. And then we get our answer of $13,494 and how many cents? Hopefully you're saying 38. Okay, sorry about that. My pen was going a little crazy. Thankfully I was able to fix it. But it would be $13,485 up and 99 cents. Oh, hold on. Was I looking? Change that. I wrote down the wrong number. So $94.30. Hopefully you guys were yelling at me. $494.38. Sorry about that. Now, the next question says, would Lori have more money in her account today if her interest had been compounded quarterly instead? So in quarterly means 4. So what they're talking about is saying we're going to use the same thing. So the 10,000 still with the same rate, except instead of monthly, quarterly as of today. Okay? And this goes to show you that this does make a difference when you're looking at your banks. Okay? So 10,000, 1 plus 0.025 divided by 4, and it's 48. All right, so plug that into your calculator. Let me know what you get. Okay, you should be getting $13,485.99. Okay? Now, would she make more money? Well, compare them. Look at that number compared to that one. Would you make more money? No. Okay, so that does matter. All right. Number 4 and number 5, I want you to pause the video. Those are all on your own. Okay? Good luck. Okay, and there's the answer and work to 4 and 5. If you have any questions, please see Ms. Carranza or myself. Last one. Rosie decided to start a saving account in order to purchase a new pool. She wants to deposit $1,000 into her account. but has the option between an account from either West Suburban Bank or Fifth Third Bank. Okay, so we're looking at two different banks. So West Suburban Bank is offering a 5% interest compounded quarterly. Okay, remember, compounded is that key word that tells us we're doing the compound interest formula. Fifth Third is offering a 6% interest semi-annually. If Rosie wants to purchase the pool in 5 years and wants to earn as much money as possible, which bank is the better choice? Okay, so let's take a look at the two banks real quick. Now, we have West Suburban and Fifth Third Bank. Now, for both of them, we would be depositing $1,000. Now, the rate at West Suburban was 0.05, and the rate at Fifth Third was 6. At West Suburban, it's being compounded quarterly, which means 4. And at Fifth Third, it's being compounded semi-annually, and semi-annually means 2. Now, both of them we're talking about 5 years. So, I'll move this over a little bit. What I want you to do is find out which one would you have more money with. You're going to do the formulas, you're going to do the calculating all on your own. Go ahead and pause the video, and good luck. Okay, so those should have been your two answers. West Suburban, you'd have $1,282, while Fifth Bank, you'd have $1,346.86. So which is the better bank? Okay. Fifth Third is the better bank, and this is why it's important to go shopping when you guys are looking at different types of loans and mortgages and savings accounts and stuff like that. Small percentages do make a huge difference, especially when you're looking at long term. Okay. All right, guys. Well, that's it for Algebra Unit 6.4 Notes, Day 2. If you have any questions, please come see Ms. Carranza or myself. Otherwise, thanks for watching.